Hello folks, my name is Alice Dallo and I'm here to teach you about a thermodynamics chemistry problem. In this problem, it says a mixture consisting of 0.201 mole H2 and 0.20 mole I2 is brought to equilibrium at 500 degrees Celsius in a 4.5 liter flask. What are the equilibrium amounts of H2, I2, and HI? Kc equals 50.2 at 500 degrees Celsius. The first thing to go about this problem is to write down our givens. Our first step is to write the respective reaction formula. Here we have H2 plus I2 goes to 2HI. Notice that both the products and the reactants match up in the number of molecules and moles. Here, for every 1 mole of H2 and 1 mole of I2, 2 moles of HI are produced. Our second step is to calculate the molarity. For H2 we are given 0.201 mole over the 4.5 liters, and that brings us to a 0.0447 molarity of H. We set up an ice table for the corresponding reaction. For C, the change in concentration, we don't know, so we are going to write down a variable for that. Let's say X. We subtract X from the initial concentrations of the reactants because those are used up. We add X, in this case 2X, because there are 2 of HI, because they are produced. Summing both I and C, this is what we end up with. Following the equilibrium constant Kc, we have Kc is equal to the products over the reactants. From here, we plug in our N concentrations from our ice table and our Kc. You can then expand this formula by multiplying simplifying both the 0.0447 x's results in this. Now we can start distributing the 50.2 to all factors of the brackets. Adding both x's together, we have simplifying the equation, we have 6.48788x plus 50.2x. Labeling the coefficients of each x, we have a, b, and c. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in all of the values for a, b, and c, this is what you get for your work. From then on, you simplify to get your x value. Remember that x values cannot be negative. We have calculated that x is equal to 0.0270. We can then plug in the concentrations knowing that 2x is HI and both H2 and I2 are the 0.0447 minus x. After plugging in our x values, we have the concentration of HI is equal to 0.054, H2 is equal to 0.0177, I2 respectively the same is equal to 0.0117. But don't forget that concentrations are usually in molarity. Thank you for watching, viewers.